Hi kids, Mr. Josephs here. Today I'm going to talk to you about pH and hydrogen concentration and the link between the two. So, first off, we know that when we're talking about an acid, it makes hydrogen ions in solution, we could also refer to it as making hydronium ions in solution. And so we need to keep that in mind. So this H plus with brackets means hydrogen ion concentration. It's not a Lewis diagram of the ion. This means the hydrogen ion concentration. Another one means hydronium ion. And for our purposes, they mean the same thing. You will see questions refer to both of these, and they do mean the exact same thing. All right, so let's see what the link is between pH and this, because there is actually a link. So if we look at pure water, H2O, a tiny, tiny portion of that will dissociate into H plus, or hydronium ions, and OH minus ions. And the concentration of pure water of the hydronium ions, or the hydrogen ions, will be 1 times 10 to the negative 7 molar. That's very, very small. It's a very, very small portion. It's that concentration of the water molecules break apart into that. And of course, the concentration of the OH minus has to be exactly the same because it's a 1-to-1 ratio between all of these. As we know, the pH of pure water is seven, right? And so you might be able to see that there's a link right here. This -7 is associated with the pH of 7. If we were to increase the amount of H plus, right, if we were to get more H pluses by putting an acid into the water, we would actually have a shift in this equilibrium. I should probably point out that this is in equilibrium going back and forth like this. So a shift in the equilibrium, let me duplicate this. So if we added some H plus so that now our concentration of H plus is 1 times 10 to the negative 6, still very small, then it's going to shift this to the left. Sorry, I didn't show this. I'm on the wrong one. Shift this to the left. And make more H2O. And it would decrease the amount of OH minus. So that would actually become -8 molar. 1 times 10 to the -8 molar. And if our concentration is 1 times 10 to the negative 6, that means we have more H plus than we did before. And 1 times 10 to the negative 7 molar, and then times 10 gives us 1 times 10 to the negative 6 molar. This times 10 to the negative 7 was a pH of 7, and now we've increased the hydronium concentration, or the hydrogen concentration, and that makes the pH go down, and this is a pH of 6. And we know that it's more acidic because the pH is acidic when you're between 0 and 7. And the formula for this is that pH is equal to the negative log 10 of the H plus concentration, or negative log of course, the hydronium, which is the same thing when we're talking about acids. And you don't need to know this equation, but it's a good idea to have an idea about what it is. But really, what we need to realize is that, let's say the pH is 3, and we changes to a pH of 5 by adding, say, a base, and we may increase the pH. How much did the hydrogen, we'll do hydronium this time, concentration change? Remember that brackets means of concentration. So I'm asking, how much did the concentration of H3O plus change? And the answer is, to change from 3 to 4, it went down by 10, because remember we're putting a base and it's going to a higher pH, so it's less hydronium. And then if we go again to the 5, it's a change of 10 again. And so the total change by decreasing a factor of 100 times. And that's how pH and hydrogen ion concentration are related.